This is Tier 1 solving simple binomial equations. There is no quiz on this one, so now we're going to solve some of these. So this one, we can add 176 to both sides. 176, and then now I need to take the fourth root to undo the fourth root of 176. So when I break this down into its prime factors, I'm looking for groups of 4. So I can start with 2 times 88. Well, 2 is a prime, I'm going to circle it. 88 can be broken down into 8 and 11. Well, 11 is a prime, 8 is not. 8 is 2 times 4, and 4 is 2 times 2. So look, here's 1, 2, 3, 4 2's, and then an 11, which will be my leftover. So I'm going to say the fourth root of 2 to the fourth times the fourth root of 11. Well, the fourth root and 2 to the fourth are going to cancel, so I just get 2 fourth roots of 11. However, remember when we did the square root of 4? So if we said the square root, we would get plus and minus 2, right? Because 2 times 2 is 4, and then negative 2 times negative 2 is positive 4. Well, the same thing's going to happen with this one. We get plus and minus 2 fourth roots of 11 because all even roots will have the plus and the minus, because that negative times the negative will be positive. So real quick, if we said negative times negative times negative, well, the negative times the negative would be a positive, and this negative times a negative would be a positive, and a positive times a positive is a positive. So now this one's going to be the same thing, but odd degrees. You only need whatever sign it is. So with this one, I can say minus 486 from both sides. And then I'm going to take the fifth root, and I can take the fifth root of a negative because that negative times the negative 5 times will give us a negative again. So that's what's special about the odd degree. So I'm going to bring out a negative 1 like I normally do. The fifth root of negative 1 is just negative 1. I'll save that for later. And then 486, I'm going to break down into 2 and 243. And 243, I'm going to divide by 9, which is 27. So 9 and 27, well, I need to break down both. 9 breaks into 3 and 3. And 27 breaks down into 3 times 9. And 9 is 3 and 3 again. Well, since I'm doing a fifth root, I need 5 of something. So I've got 1, 2, 3, 4, 5 3's, and then I have a leftover 2. So what this means is 3 to the fifth, and I take my fifth root times the fifth root of 2. And don't forget about our negative 1. Well, we have some cancellation. We get 3. And then that negative 1, 3 times negative 1 is negative 3. So I'm just going to do that right now. And then I've got the fifth root of 2. And I only need that negative 1. Okay, so my odd degrees, I only need one of them. If I do an even, I need plus and minus. With even degree polynomials, we need the positive and negative solutions, which I mentioned above.